DMVPN. DMVPN stands for Dynamic Multi-Point Virtual Private Network. Dynamic multi-point, that's the key here. Why this VPN is special? It can form VPN with multiple clients. It can have multiple sites. And that too, the tunnel is formed, the VPN is formed dynamically. So before this DMVPN, we also have one more static VPN called GRE tunnel. GRE is like point-to-point. It's a point-to-point tunneling. GRE is a point-to-point tunneling. Whereas DMVPN is the multi-point tunneling. The base is same, both use GRE. But here it is multi-point, there it is point-to-point. Now what is the advantage of having multi-point and what is the advantage of having point-to-point? See, these multi-point tunnels are dynamically built. Tunnels are dynamically built. Whenever a new client tries to form a tunnel with our head office, the tunnel is dynamically built. So head office need not to know about all the spokes, all the clients. Tunnel is not statically built between the head office and the branch offices. They are dynamically built. And if the tunnel is not in use, the tunnel will be teared down. Now, is it a secured VPN? This DMVPN, is it a secured VPN? No, not by default. It is a secured VPN. It is not a secured VPN. It's just an encapsulated concept. The packets are encapsulated with GRE, and packets are routed with the help of routable address. So instead of GRE point-to-point, we have GRE multi-point. We call it as Dynamic Multi-Point VPN, DMVPN. It is not a secured VPN by nature. But we can add IPsec to this and provide security. We can add IPsec to provide security. So today we are going to do this lab in two different sections, two different we can say steps. First, establishing a DMVPN, Dynamic Multi-Access VPN tunnel, which is not a secured VPN. It is just a dynamic tunnel that is getting established. The advantage of having a DMVPN is it's scalable. Whereas static GRE tunnel, it is not scalable, right? We need to construct multiple tunnels with multiple sites. If it is a normal GRE tunnel, we need to have, if you have 3 sites, remote sites, then you need to have 3 tunnels. Whereas here, Dynamic Multi-Point VPN is not like that. You do a configuration which is common for any number of tunnels. You don't go and alter the configuration. So this is more scalable solution, but by default this GRE tunnels, DMVPN is also a GRE tunnel, but it is dynamic multi-point tunnel. So by default these tunnels are not secured. We always add IPsec to this to form a tunnel. Now how this work? To understand how this works, now let us have a small topology here and discuss. We will take routers like this, let's say R1, and R2, R3. We'll simply take 3 routers. and I'll keep one switch in the middle and connect like this. Now, just in our lab environment, we use switch here. It need not to be a switch, it can be a big internet cloud. And let's say this is the hub or the head office, and these two are spokes. Spokes 1, spokes 2. 2 spokes router or the remote branch offices. Let's assume they are in 3 different locations. Not in same location, 3 different locations, and each office is connected to an ISP, and through ISP you are able to ping from R1 to R2, R1 to R3, and R2 can reach R3 via R1. That's why we call it as hub router. R2 can reach R3 like this. Happening. No, like this. They can talk. So you can also see like this, R1 can talk to R2 and R2 can talk to R3. This is the physical topology. Let's have some private network, or let's have some let's simulate a inside network. I'd like to have inside like 1.1.1.1. Assume that this is our inside network in head office on the hub, and this 2.2.2.2 is the inside network in the remote office 1. I'll give all this in the loopback interface just to simulate the inside network. We are doing this, and R3 has got 3.3.3.3/32. Now, what's the idea behind this DMVPN? It is this: R1, R2, R1 and R3. This will form a kind of static tunnel, that is not dynamic tunnel. See, this R1 and R2 can reach each other. Let's say the IP address on here is 192.168.123.1, and here it is 192.168.1, router 2, router 3. Simply I'm putting like this 2/24. Here also /24. Here also 192.168.123.3/24. So we got this network. Assume these are all public network. This is not public. Assume it's a public IP, whatever. We need to reach each other. That's all. We have a switch now here. We don't have a big internet cloud, so it's okay if you have 192.168. All that you need is reachability. You need to be able to ping. You're able to ping R1 to R2 and R2 to R3. There should be reachability. Now this reachability is there, and the spokes router R2 and R3 will establish the tunnel like this: R3 and R2, R1 and R2. Let me put it in different color. R2 and R3. It forms a tunnel, a kind of static approach. R2 will know who is hub. R3 will know who is hub. So R2 and R3 comes and registers with the hub router. It forms a tunnel like this. And now R1 knows about R2. It also knows about R3. So with the help of R1, now what R2 can do is, R2 can form tunnel with R3 like this. See, R2 and R3 has no direct contact. There is no direct contact, but still R2 and R3 can form tunnel directly like this. But on R3 you do not configure R2 as a spokes. On R3 you do not configure R2 as a spokes. Likewise in R2 you don't configure R3 as a spokes. All that you do is you configure R3 to form tunnel with R1, R2 to form tunnel with R1. With the help of R1, now R2 can learn about R3 and dynamically form spokes to spokes tunnel. So tunnel between spokes to spokes is a dynamic tunnel.
So one doubt, sir.
Yeah, what is that?
So once R3 learns about R2, what is the path it will select, sir?
Very good, very nice question. R2 and R3, they don't know each other directly. They learn using R1, which is hub router. But will the traffic always go through R1? No. You see, you can have something like this. Like this. You can have, through switch, you can go like this. You can go like this through switch. Right, so it is not always the traffic goes through R1, but there are some conditions where you will see traffic always going through R1, but you can overcome it. Especially when it comes to a distance vector routing protocol like EIGRP. We'll talk about that when we go to routing protocol. But R3 and R2 will form dynamic tunnel between spokes to spokes, and it need not to go through the hub always. Only initial stage in while learning each other, R1 and R2 and R3 while learning each other, R2 and R3, they go through R1. Once they learn, they know how to directly see this, and this can be pinged via switch. So because there is an IP path, they can form tunnel. Sorry, they can send traffic directly. They can send traffic directly. So initially to learn R2 to learn about R3, it needs R1's help, and vice versa. Once they form adjacency, once they form the dynamic tunnel, then they do not go through R1. They can go directly. So this red line that you, sorry, not red line, let me draw a red line. This red line is dynamically formed tunnel, and they can talk like this directly once the tunnel is established. But this tunnel is established without you configuring nothing about R3 on R2, or you configure nothing about R2 on R3. So let us have a brush up what happens here. R2 goes and registers with R1, and R3 goes registers with R3. R3 goes and registers with R1. Now R1 learns about these two spokes, and whenever R2 wants to go to R3, it don't know where is R3. It sends a query to R1, and R1 gives the information about R3 to R2. R1 gives the information of R3 to R2. What information? R1 will give the IP address to reach R3. And with the help of that, R2 by itself can come down to R3 and form a tunnel. All that R2 needs to know is where R3 is located. That information will be given by R1. How R1 knows? R1 knows because R3 registered with R1. So this is how it happens. So for doing this IP address alone is not enough. This is a public IP address which you ping. On top of it, you need a tunnel IP address. So let us use tunnel IP address like this. Let me say 172.16. Same 123.1. Here on the tunnel 172.16.123.2. Here 172.16.123.3. So these are the IP addresses that we are going to have on the tunnel interfaces. And by using this tunnel, tunnel IP address, they can negotiate tunnel using GRE multi-point, and they can establish the tunnel. Once the tunnel is established, spokes to spoke also can establish the tunnel dynamically with the help of the hub router. This is our first step. Second step is providing security to this DMVPN. For that we will be using IPsec. IPsec has got two phases, phase 1 and phase 2. Phase 1 is to negotiate the key. The key sharing happens in phase 1, and once the key sharing is done, they negotiate the transform set through which the packets can be encrypted and decrypted. Once that is successful, the tunnel is secured. So let us first of all do this DMVPN without security. Now once you have done this DMVPN thing, you will be seeing that 111 can ping 222 and 333 can ping 222. Further, what we will do is we will have one common routing protocol over the inside and the tunnel. Let me repeat. I'll have one common protocol. Let me say here EIGRP and here EIGRP. Only on the tunnel interface and on the loopback interface. I don't have EIGRP on the Ethernet interface. I'm not having EIGRP here. No EIGRP. No EIGRP. No EIGRP. I have EIGRP on the tunnel and the loopback. On the tunnel and the loopback. So now you can see here that though this physical interface don't have EIGRP, still these networks will be advertised. The loopbacks will be advertised to the other routers via the tunnel. That's the proof the tunnel is working. In case if I will have a router here, these networks will be different. So I may be running some other routing protocol like OSPF only for the public IP address reachability, and you will not see any route for the loopbacks on the middle router. You will not see 111, 222, 333 on the middle router, on this router, but still the packets will be forwarded to reach 111, 222, 333. That is possible because the non-routable packets are not exposed to the middle router. They are encapsulated with the GRE. According to this middle router, all that it will see is router 1's source address and router 2's destination address. It won't see the real source 111 going to 222. I have explained these scenario in my other videos. You can see that in our channel. where I use a routing device in the middle. But to make it simple, I just taken switch so that we can concentrate only on DMVPN, not on the other routing part. So we do not have any routing protocol on the fast Ethernets. We do have only on tunnel and the loopback interface. And using the tunnel, these routes will be advertised to the spokes routers, and now spokes routers can ping the loopbacks using the spokes. So this is our first step. In this first step, there is another sub-step. What is that? Now, because you use EIGRP, now what router 3 will learn is, router 3 will learn like this. 2.2.2.2 is via, let's say this is fast Ethernet 01, is via fast Ethernet 01, and the next hop address is 172.16.123.1 tunnel 0. This is how it will learn in the routing table, R3's routing table. But actually 222 is where? It is on R2. So instead of this number 1, I should receive 2, only then R3 can directly send traffics to R2. But by default, you will see the hub router's IP address as the next hop address. The reason is you learn this from the hub router. So you will find only hub router's address. To overcome this, I need to go to R2 and say no EIGRP 10 next hop self. So this 10 is talking about the autonomous system number that we are going to use all over this topology. And I need to say, hey, I'm not the next hop. I am not the next hop. So when you say this command, what happens is R1 while advertises, it will not put its own address like this and send. Rather, it will just carry their original source address, which is 2. Router 1 is learning from 2, so it will just pass on without changing, without swapping its own address. So without changing, it can send the update to R3. Now R3 knows the actual destination to reach 2222. Now using GRE tunnel, it can reach this destination. So using the tunnel 0 interface, it will deliver this traffic to 2222 like this. So GRE is very important here. So actually it will resolve the public IP address 192.168.123.2 and delivers to that address, and that address the tunnel endpoint that can decrypt the packet and see the actual destination and delivers the packet there. So what I'll do is I'll also sniff some packet and show you today how it really works. So this is one command. No EIGRP 10 next hop self is one command, and there is one more command. What is that? Split horizon. No EIGRP 10. No IP split horizon for EIGRP 10. That is the command. No IP split horizon for EIGRP 10. What will this command do? Now if I don't give this command, whatever R1 learns from R2, it will not give to R3. whatever R1 learns from R2, it will keep it with itself. Meaning, about 2222 network, R3 will never learn because R1 will not give. Likewise, 333 network will not be learned on R2 because R1 will not pass it on to R2. The reason is split horizon is on control. What is split horizon? The route that you learn on an interface, see this 333 network is learned via this interface. It should not advertise back about that same 333 on that same interface. That is what split horizon. Whatever you learn, don't give it back on the same interface. So if you don't give it back, then how R2 will learn? R2 will never learn. So to override this, what we do is, we say no IP split horizon for EIGRP 10 alone. You cancel that split horizon so that whatever R3 gives to R1, R1 will share to R2, and whatever R2 gives to R1, R1 will share to R3. So this is our first step, having DMVPN without security. Once we finish this, we'll come back and discuss about providing security to this DMVPN, and we will provide security using IPsec. Now this is what the physical and the logical topology is going to be, and we got our loopback and this black color number, that is talking about the IP address over the interface. We got a switch, and again IP address over the interface. Since you have a switch, they all will be in same subnet and they all need to reach each other. Definitely they will reach each other because you got just a layer 2 in the middle. In real world, we will have a big internet cloud where this physical interfaces will not be in same subnet. They will be in different public domain, public IP addresses, but still they are connected to, though because they are connected to the internet, you can able to ping the public IP address. All that we need is reachability between these three routers over the physical interface. So I'm going to quickly configure this. First of all, I will not concentrate on TO interface, tunnel interfaces. Tunnel 0 interfaces we will not configure. We'll do the basic configuration first with the loopback interface. So these color networks are private networks. This 2222.11.11.3333. These are the networks that will be using the tunnel that which we are going to create. I'll create the tunnel interface later. Let us first finish the basic configuration. I'll quickly use a notepad to finish this. I'm on router 1. I'll say enable config T interface loopback 0 IP address 1.1.1.1 255.255.255.255 interface gig ethernet 0/0 IP address 192.168.123.1.255.255.255.0, and there is no other configuration needed. So I'll say exit or end and write to memory. This is what goes on router 1. So router 1 configuration is over. Let's do router 2 and 3. All that I need to do is just put 222 and 192.168.123.2, copy and paste it. Router 2 is also ready for us. Next is router 3. So we got this on router 3. I'll paste this on router 3. Here we go. Done. So next is, when this configuration is done, we are ready to go with our tunnel configuration, the GRE multipoint. I'll explain every command. I'll explain the need for those commands and everything. Before that, let's try pinging these devices. I'll ping from here 192.168.123.1. It should ping. It is, and 2. It is pinging. So this reachability is what we need to negotiate tunnel. Now R1 can ping 192.168.123.1, sorry, .2, as well as 3. Right, if this reachability is there, we are good to go. I'm on R1. I'm creating a virtual interface called interface tunnel 0. Now why do you need this interface? Now this interface going to have the tunnel parameters, encryption parameters, sorry, not the encryption, encapsulation parameters. You know what really we do here? We are going to take this packet coming from 1111 and encapsulate with, or put another cover over it. On that top cover we will have this IP address 192.168.123.1 as the source IP address, and if you are pinging 2222, then this will be the destination IP address on the top layer 192.168.123.2. so that encapsulating thing you need to mention on the interface, but you cannot mention it on the physical interface. We do it on a logical interface and map it to this physical interface. So yeah, what's your doubt? Now the question is, do we need to have routing between router 2 and router 3? Yes, you should have routing between router 2 and router 3. Why? The reason why is, you know, router 2 and router 3, after they learn each other from R1, they need to negotiate tunnel and form dynamic tunnel between them. To negotiate, they need to have the physical interface reachabilities. This physical interface G0/0 of R2 should reach R3. Now, what your tunnel can carry is only the inside network. Traffic from 3333 will be carried to 2222 using the tunnel. But to form the tunnel, you need to have the reachability between the physical interface.
Got it.
Right. Now we have just got the interface tunnel 0. Now we need to get inside it and give an IP address first. I'll say IP address is 172.16.123.1, 255.255.255.0. Now this is for tunnel identification. For router 2 and router 3 to identify the GRE neighbors, we need some ID. So we give this ID. This is for the tunnel interface. Tunnel interface is saying this is my IP address. Okay. Next. As I told you, tunnel needs to be tuned to this mode called GRE multipoint. Why? We are doing DMVPN. DMVPN. So we got multipoint GRE, dynamic multipoint VPN. So if you don't say this, what will happen is it will be a point-to-point GRE. If you do not say tunnel mode GRE multipoint, it will be like tunnel mode GRE only. Multipoint, if you don't say, then it will be a normal GRE tunnel, static tunnel, point-to-point tunnel. It won't be a dynamic tunnel. So when you say tunnel mode GRE multipoint, you are enabling DMVPN. Done. Next is from where you start your tunnel, or on which interface you start your tunnel on this router. It is interface G0/0. So we need to say tunnel source. On this router, it is G0/0. From here only I'm starting my tunnel on this router, R1. The physical interface address. Using this physical interface address, you negotiate tunnel to this box. That's the meaning of this. Next, there is another command. This is 3 new commands that you are going to learn now. You understood IP address, you understood why we need the mode GRE multipoint, and you understood why the interface. Now the next is very important, which is IP NHRP, next hop resolution protocol. This is the protocol that makes DMVPN to resolve the next hops. IP NHRP map, see if you put question mark, you can see there map here. Map the destination IP address of non-broadcast multi-access address. Now what is the meaning? I'm saying my next hop is a multicast. It's a multicast dynamic. What is this meaning? This command will automatically add the routers to the NHRP mapping table. This command will dynamically learn, this command will add R2 and R3, or let me put in simple term. This command will register when R2 and R3 comes to register with R1. When R2 and R3 comes to register with R1, R1 will say you're welcome. You're welcome. And it will take those information and put it into the NHRP mapping table. So in order to do that, in order to learn the incoming registration, dynamically, we give this command IP NHRP multicast dynamic. So this command is used by this all routing protocols. See why I use multicast word. All routing protocol uses multicast to form neighbor. So when EIGRP and R2 and R3 sends the multicast traffic, this will learn those addresses dynamically. So this is not actually, I think I said wrong in the beginning. This is not going to be used for tunnel registration. This is going to be used by the routing protocols to register. R2 and R3 running EIGRP, they send hello packets. They send hello packets as what? They send hello packets as a multicast. When such multicast traffic comes, the source IP address from where the multicast is coming will be dynamically learnt and added to the next hop mapping table, next hop resolution protocol mapping table. So this is used only when you have dynamic routing protocols like OSPF, EIGRP and so on. Next is, now you may have many routers in this topology, but you want to form tunnel only with R2 and R3. You want DMVPN only on R1, R2 and R3. So you need to have a unique ID to identify the group. In order to identify the group, you need a unique network ID. So what we do is, we give this command called IP NHRP network ID. And this command is a common command It's a same command, and whatever the number you type here, it should be the same number that should be typed on R2 and R3. This is a common command. You will be repeating this command on R2 and R3. Next is, optionally you can authenticate each other. IP NHRP authentication. In order to have a secured, I don't want to form DMVPN with anyone who wants to form with me. I want to form DMVPN only with those who got the same password. So, the password, let's say, Cisco _ DMVPN, C _ DMVPN, something like this. You have a unique password. Now, whoever comes to register with this R1 should carry this password. Only with them R1 will handshake. Anyway, it's an optional command. It is not a mandate command. Okay, that is IP NHRP command. What is next? Next is, let me quickly check what all we did. Do show run interface tunnel 0. So far what we have given is this IP address we have given, and we given authentication, and we said multi-point dynamic, this and this. There is one more command called tunnel key. Tunnel key. And this tunnel key is any number between this range. And this number also should be same. This also used to identify the tunnel. And few people don't use this thing. They think they take it as optional. Yeah, this is also optional. Even if you don't have it, works. But it's good to have a tunnel key. Now, if you put tunnel key 1 here, then you need to put same number on the other routers. Alright. So let us have again one more time what all we did. Do show run. So we have done on the hub router, we gave an IP to identify the tunnel. We have given a password so that we will not form with any way. We will form neighbor only with those who have got this password. And we said whenever a multicast traffic comes from any routing protocol, you can dynamically learn them and map it, put them into the NHRP mapping table. But they should carry this password, and they need to come from this group, network group. NHRP group is 1, tunnel group is 1. They should come from here. And the mode is MGRE. You know the reason why we need this, in order to enable DMVPN. And this is the physical interface through which all this negotiation shall happen. Is this clear?
Yes, sir, it's clear, sir.
Right. So now let us go to the other side, spokes. Over the spokes, the command, most of the commands are same. Only 2 additional commands you will see. So I am saying interface tunnel 0. IP address, as you know, it is 172.16.123.2. Let us put all the common commands, whatever you configured on the hub. If it is common here on R2 and R3, let us put that first. As I already told you, the mode is common. Tunnel mode is GRE multi-point. This is a common command on all 3 routers. And as you already know that the password should be same. IP NHRP authentication. I think I gave there under C _ DMVPN. It should be same case. Whatever the special character I used there, same. Everything should be same. So this is also well known for you. And then IP NHRP, I told you network ID should be same. IP NHRP, network ID, I think I gave 1 there. Here also I give the same thing. And this is also a common command. And then tunnel source will be this physical interface now through which we are going to negotiate. So I'm going to say gig Ethernet 0/0. Now these things are common. What are the things that are not common? I think one more command, tunnel key. You remember I gave tunnel key there. Tunnel key, I gave 1 there. So these are all common. Let me show it again. Do show run interface tunnel 0. So these configurations are ditto copied from R1. There is no additional new things you see here on the screen. It's duplicate, a replica of what you did on R1. Now what we are going to do in another 3 lines are new on the spokes. Just 3 lines. What is that? I told you in the beginning, R2 and R1 will statically come and register them with R2 will come and register with R1. I told you R2 and R3 will come and register statically. R2 will come and register statically. R3 will come. For that we need to tell R2 where 172.16.123.1 is. See, R2 should negotiate with this tunnel interface on R1. But how R2 knows about the tunnel interface location? R2 knows only how to reach 192.168.123.1. It don't know about 172.16.123.1. So we need to say, in order to go to 172.16.123.1, you go to 192.168.123.1. You understood? In order to go to this tunnel interface, with which you need to negotiate DMVPN, you need to go to this physical interface. So that command is like this. IP NHRP map command. See, it makes sense. You are mapping. You are saying map. If you want to go to 172.16.123.1, which is the hub router, if you want to go here, you need to go where? 192.168.123.1. Go here. This mapping we need to do. We need to tell where to find the other tunnel end. This is why I call it a static registration. I'm telling go here and you will meet someone called 172.16.123.1. Talk to him, negotiate with him, next stop, resolution protocol. And then one more thing, for the routing protocols, you remember we used on R1 we used this command. Why we use this command? Why we use this command? So that when EIGRP and OSPF comes and registers, they will be added to the NHRP map table. Now, if R1 and R2 come and if R2 and R3's EIGRP or OSPF, if they need to come and register here, that I need to mention that statically. How? I'm saying, hey, you need to send IP, NHRP, all the multicast traffics. IP, NHRP, I think map one more time. Map all the multicast traffic you map to, meaning you send all your multicast traffic to the hub router. Who is your hub router? 192.168.123.1. Don't give the tunnel interface address. You need to send to this physical interface address, and that physical interface address is ready to welcome you.
Okay, sir.
So that physical interface address has got the tunnel interface on it, and that is there to happily welcome you. So I'm saying send all your multicast traffic, OSPF, EIGRP, send all your traffic to this guy. Say hi to this guy. All your multicast highs, hellos. And there is someone who is there ready to dynamically discover you. So this is only for the routing protocol. And this is for you to register to form DMVPN, static binding. And what else? There is one more command, just one last command. Just 3 commands you are learning new here. Another one is IP NHRP. Again NHS, next hop self. Next hop self is different, NHRP is different. So next hop self command. So we need to give this command to set the IP address of the next hop self. I'm saying IP NHRP 172.16.123.1. I'm saying this is my tunnel's next hop. You're doing static tunnel here, right? Between R2 and R1. So, hey tunnel, for you, the next hop is this. How you will reach this next hop? You go here. And then what should I do if I need to form a routing protocol dynamic discovery? I need to send all the multicast traffic to this one. So it makes sense. 3 simple commands. Let me show you those simple commands. Do show run interface tunnel 0. These are the 3 new commands we typed. These 2 and this one. Only these 3 commands you need to remember for the spokes. People will get confused here. Where? Only in this 2. This one and this one. Very easy. See? My next hop for my tunnel is the tunnel IP address. Okay. Now how to go there? That's what the map command says. To go there, you go here. This is a reachable address. For R2, this is a reachable address. The physical interface of the hub. Give the physical interface of the hub. You go here. That solves the problem. And this is for your multicast, for your routing protocols. And they need to send it not to the tunnel interface, but to the physical interface. That is taken care when you send it to that physical interface. The hello packet should be sent here. See, you cannot send hello packets to a non-reachable address. This address is a reachable address. So you send it to this one. And then, all the negotiation will happen because the key is matching on both the side. Password is matching on both the side. And what else is matching? Network ID is matching on the both side. And they're going to form neighbor. So this is what the configuration that is needed on R2. Now same configuration you're going to do it on where? On R3. Let us do it quickly, without hesitation. You're going to give me some commands and I'm going to type it. Interface tunnel 0. Tell me what I should do. What's the first command? IP address, correct? 172.16.123.3 255.255.255.0. Okay, what is next? Tunnel mode command. Okay, tunnel mode command.
Multipoint.
Tunnel mode GRE multipoint. Next is tunnel source command. From where you want to source. From gig ethernet 0/0. And then
Okay, sir.
next is what? Tunnel key.
Destination.
No, we don't say destination. We don't say destination here. nowhere we say destination. Okay. If it is static, then we will say destination. This is DMVPN. We never use the word destination in DMVPN. If I use the destination, then it will not be a dynamic multi-point VPN. It will become a static multi-point.
Okay.
Right. Next is what? IP NHRP authentication. C underscore. Okay, let me give you a clue. 3 tunnel commands. 1, 2, 3. Got it? 3 tunnel commands.
Yes, sir.
4 IP NHRP commands. Okay? Okay, with
Yes, sir.
okay, including authentication 5. 3 and 5. 3 commands starting with tunnel, and if authentication is there, then 5 commands starting with IP NHRP. If no authentication, 4 commands. Okay. So IP
Got it,
NHRP authentication. C, I think I gave C DMVPN, right? Cisco DMVPN.
Yeah.
C DMVPN. So 1 out of 5, 1 is already over. Next is IP NHRP network ID 1. You know this. So 2 is over. Out of 5, 2 is over. Just 3 commands.
Yes, sir.
And you know what it is. You see, IP NHRP next hop self. What address I need to give? The tunnel IP address. 172.123.123.1 tunnel IP address of the hub. Okay. Now, how I go there? I don't know how to go there. That I need to say map command. Map. If you want to go to this address, go to where? 192.168.123.1. Does that make sense?
Yes, sir.
Alright. What is next? See, already out of 5, 4 is over. The one is for the routing protocols. For the routing protocol, the command starts with same IP NHRP, map, but this time we are saying multicast. Correct? Because for the routing protocols, they use multicast address to form neighbor. I'm saying send all this multicast to the physical interface address of the hub. Is it right?
Yes, sir.
Okay, that's all. You did a good job now. Show run interface. Do show run interface tunnel 0. You see, everything is in place. Everything is in place. You got the IP address, you got the authentication, you know where to send the multicast traffic, and you know how to reach that address. To reach that address, I need to go here. See, this is where people make mistake. Even in exam, if you are doing troubleshooting, if it is not, the DMVPN is not coming, you know what mistake? Everything will look nice. This address, they would have put here. They would have swapped this address. 192 will be physical interface, they will write here, and the tunnel interface, they will write here. Wrong.
Okay, sir.
See, IP NHRP map. You see what it says? It says, what's the IP address of the destination? What destination? You are on the tunnel interface. You need to provide the tunnel destination. Is that right? Tunnel destination is what?
Yeah.
16.123.1 and put question mark. Now it is asking me what will be the IP address of NBMA network. What is NBMA network? The NBMA network is the one which you are trying to form VPN. The physical IP address of the R1. Right, so that's a clue. Always NBMA address comes second, meaning, you know, the physical address comes second. So that's the only place people get confused. Other things are okay. Sometime in exam, this also they may put 192.168. It should not be. It should not be. Remember one thing. always tunnel IP address comes first and then comes the physical IP address. Only when you send the multicast traffic, you will be sending to the physical address. Remember, routing protocols, I send it to the physical address. Other than that, everything will have tunnel address at the first. Tunnel IP address will come first. Only to send my multicast traffic, I cannot send to the tunnel which is not established. I can send only to the physical address. Tunnel is not yet established. Going to establish. Is that right?
Yes, sir.
Alright. So that's all the DMVPN configuration is. Now we are going to quickly go and examine. I'm going to type few commands and show you whether the DMVPN has come or not. I'll go to router 1 and type in this command here, show DMVPN. Look at this, how nice it is. But okay, this is very superb output, you can say. But I didn't show this command in any other video before. I use only NHRP command. That's more user friendly, but this is also nice. You see, it shows with whom the tunnel has been already registered. See, router 2 has come with this physical address and it has said, hey, my tunnel IP address is this, take it. I didn't give these things on R1. I didn't give. You know that I didn't give it. See, router 3 has said, this is my physical IP address. I'm using this tunnel IP address. And both the guys have agreed. You see, they are up now. And how long they are up? This many minutes and this many seconds. What is the attribute? D means what, you know? Whether they are dynamically learned or statically. Dynamically learned. R1 has learned R2 and R3 dynamically. R2 and R3 voluntarily came and registered with R1. Let us see the same command on R2. You will find some difference there. Show DMVPN. It says, I know only one person called router 1 and I'm up with him statically. You see that? That's what I was saying in the beginning. R2 will go and form association with R1 statically. Likewise, R3 will form with R1 statically. Why I am not seeing R3? You are not seeing R3 because you didn't try pinging R3. Only when you try pinging R3, R2 will go to this hub. Hub, you are my everything. Please provide me if you have information to reach R3. It will go and beg R1. It knows how to reach R1. It will go and ask R1. And R1 knows about R3 and this information will be downloaded dynamically to R2. After some time I'll come and show you here. You will see one more. That is R3 information. Likewise on R3 if you see, you don't see R2 here. Show DMVPN. You don't see R2 here. But after some time we are going to ping between R2 and R3 and the ping will happen. After that if you come and see here, you will see the other peer not statically but the other peer will be dynamically learned here through hub router. Okay, before I go to those type of verification, I would like to show you one more verification, one more nice command. That is on R1 show NHRP. Show NHRP. Show IP NHRP. See, it shows a table. This is very nice table. This one I show in my previous video also. It shows that there is one person called 172.16.123.2 and that person you can reach via this one. See, because we don't have route layer 3 here, I see the same address repeated here. To go here, go here. But in case if I have a router here, in this place I'll see the router's interface address and
Okay, sir. Got it.
this final destination. Now it says in order to go to this tunnel IP address, you need to go to this physical address. In order to go here, you need to go here. Now this guy has, R1 has got information about R2 and R3. But when I go to R2, same condition, I don't see R3. Show IP NHRP. I don't see R3. So let us ping now. After pinging, you will see a lot of difference. Let me ping just the, not the loopback interface. I am going to ping the tunnel interface. Loopback, I didn't enable routing protocol, so we'll come to that one later. Let's do tunnel pinging. I am pinging the router 3's tunnel address. 172.16.123.3. It started pinging. Now let me take you to router 2's DMVPN command. Look at this. It has learned router 3's address dynamically just 7 seconds ago. While I was pinging, this resolution happened. And you see, it knows how to go directly to that guy. It is not going through hub. It is going directly. What is the proof? I trace route. You see, direct communication. I don't see one here. Direct. It can talk. So spokes to spokes tunnel is dynamic. Now let us go to router 2 and check this table. Sorry, router 3 and check this table. Router 3. Look at this. This guy also has learned about 2 because the packet was coming from there. Dynamically it was learned. Now let me show you the other command, IP NHRP command. Show IP NHRP. Previously it was not knowing about router 2. It was having only router 1 information. This is router 3 itself. This is router 3. I am on router 3. This is router 3 itself. It is local. Previously it was knowing about router 1. But now it has learned about router 2. Router 1, how it knows? Because of your static configuration. But router 2, how it knows? Dynamic. And this is in use. Here it says never expired because you statically configured. This will expire after this many hours, and it is in use. So this is what the DMVPN is. Now what I'm going to do is I'm going to configure 2 routing protocol. First, let's test with EIGRP.
Okay, sir.
And then we'll remove EIGRP and we'll put OSPF. In both this thing, we have something to learn. So let me start with EIGRP. I'm going to say router EIGRP 10, network, whatever the network that is there in the tunnel, 172.16.0.0. This is one network on the tunnel, and then network 3.0.0.0. No auto summary. So these are the 2 networks. I am not running EIGRP on physical interface. I am not running. So R3 will not form neighbor with R1 and R2 using physical interface. Only via tunnel it can form neighbor. Already tunnel is there. Now it can speak to R1 using the tunnel. It can speak to R2 using the tunnel. Alright. Now it is done. Let me do the same thing on R2 and R1. On R2 I am saying router EIGRP 10 network 2.0.0.0 network 172.16.0.0 no auto summary. Right. Now going to R1. Now I want to show you something here. I have not configured. I want you to answer here. This is very important place. The secret to understand the actual logic. R2 and R3, now they are able to ping, right?
Yes, sir.
Then why I didn't see neighbor? Show IP EIGRP neighbor. Why R2 and R3 didn't form neighbor? The reason is show run interface tunnel 0. Here is the reason. It is sending the multicast traffic to R1 for EIGRP registration, correct?
Yes, sir.
But R1 don't have EIGRP now. I have enabled EIGRP only on R2 and R3, is that right? I enabled EIGRP on R3 and I enabled EIGRP on R2. R2 and R3 are sending to R1, but R1 is not responding for EIGRP multicast traffic. Unless R1 is ready to form EIGRP neighbor, R2 and R3 cannot form neighbor. See, R2 R3 neighbor is only through neighborship is only through R1. Once they form neighbor, routes can go directly from R2 to R3. You understand? Neighbor establishing is only through the hub. Why? All your multicast traffic, EIGRP is right now sending hello packets, but you don't know to whom I need to send because it's a tunnel interface. So I gave this command to send it. It is sending to R1, but R1 is not responding to it. R1 is not responding to it. I would like to show you that. See, R1 I have not enabled EIGRP. Let me show you one more time. R1 show IP protocol. I don't have any protocol. You don't have EIGRP. I have only NHRP protocol running. Correct? There is no EIGRP running. Now I'll debug and show you, or I'll do one thing. I'll use packet sniffer. I'll sniff packets. I'll show you that EIGRP is talking to R1 now. But R1 is not there with EIGRP. See, R1 has got the command to learn dynamically. Those things are okay. But EIGRP should be there, no? Only when two routers have EIGRP, they can form EIGRP neighbors. R1 is ready to learn from NHRP perspective. From tunnel perspective, it is ready to learn. But
Okay, sir.
from the routing protocol perspective, still R1 is not ready. If R2 is sending the multicast traffic to this address 192.168.123.3, it would have formed a neighbor already. But we have not configured like that. We have configured to send it only to router 1. Look at this. R2 is sending hello. See, this is R3's address, correct? R3 is sending hello to this multicast address, and you see here. See, it is sending actually the traffic to the multicast address. I want to make a study here. Look at this. Look at this. Layer 2, layer 3. The actual packet, the EIGRP is running on the loopback, correct? See. This is the loopback interface of R3. Sorry, tunnel interface of R3. From this tunnel interface, packets are sent to multicast address of EIGRP, correct? But
Yes, sir.
where the multicast packets are sent, you see GRE is there, and GR generic route encapsulation. On top of it, you got the actual physical source and physical destination. This destination is because you gave that command what? You gave this command. You
Map multicast.
map multicast to that particular address. So because we gave that, on R2, because we gave this address, all the multicast traffic, what traffic it is, 224.0.0.10, it's a multicast traffic. It is mapped to this physical address. Right?
Got it,
The
sir,
physical address of the hub. So the packets are right now going to R1. I captured this packet right on the R1 interface. Right? I captured this right on R1 interface, and I am showing you. Now what I'll do is I'll enable EIGRP on R1. Router EIGRP 10, network 1.0.0.0, network 172.16.0.0, and no auto summary. So auto. Now what you see here is using tunnel 0 they form neighbor, right? So when I go to router 2, show IP route, I can see that I can reach 1111 with my source loopback 2222, that is 0, loopback 0. So I can ping loopback to loopback, it is pinging. It is using the tunnel. But what I am not seeing is about router 3 information. I'm not learning 3333. If you want to learn 333, you need to cancel the split horizon on R1. How? Interface tunnel 0, no IP, split horizon for EIGRP 10. When you give this command, you will find the route of R3 on R2. Previously I was seeing only 1111. Now I can see 3 also. Yeah? Now what I'll do is I'll trace route 3333. Now you see it is going via hub. Do you see that?
Yeah.
It is not going directly. But I know the tunnel is direct. Spoke to spoke tunnel. I have direct connection. Then why it is going like this? The problem is the routing protocol. Look at this. The routing protocol says that in order to reach 333, you need to go to router 1. Now if this is changed from 172.172.16 123.2, sorry, 3, instead of 1, if I have 3 here, then I can go directly. To do that, what I need to do is, on the hub router, I need to say IP EIGRP, no next hop self, no IP EIGRP. No IP next hop self for EIGRP 10. Okay, I'm saying router 1, don't take the responsibility of becoming a next hop. Don't take that responsibility. Now if I go and check on R2, previously when I traced this, you saw me going 2 steps. The reason is the routing table was like that. Now you see the routing table changed.
Yes, sir.
If I trace route now, I can go directly. You understood the meaning of those 2 commands?
Yes, sir. Got it, sir.
2 commands. No IP, need to cancel it. No IP, next hop self EIGRP 10. And then no IP, split horizon EIGRP 10. So this is what you see in EIGRP. One more
Okay, sir.
show command I want to show. This is very important. I'm going to have R1. On R1 I'm capturing the packet. I'm going to ping from R2 loopback to R1 loopback. R2 loopback to R1 loopback. Okay? Don't see this EIGRP packet. I want to show you the ICMP packet. So I'm going to ping from R2, ping 1.1.1.1, source 2.2.2.2. Shall I do this?
Yes, sir.
Alright. Look at this. I'll pick one ICMP packet coming from 2. Yep. Okay. Now your focus need to be only here. You see, the packet is going from what packet? ICMP packet, Internet Control Messaging Protocol. The ICMP packet is going from 1.1.1.1. That's the source, and going to where? 2.2.2.2. That is not going to be revealed to the cloud. Why? It has been GRE. It has been tunneled. Generic route encapsulation. It tunnels it. What the tunnel is doing is, it is putting the source address of router 1 and destination address of router 2. Wait, I'll capture another packet and show you. Actually, we were pinging from router 2. So let me show from router. This is packet from router 1 to router 2. This is a return packet. I want to show you the packet that was coming from router 2. Okay. Now you see here. Okay, the packet is, okay, here is the source. The packet is going from 2 and trying to reach 1111. So source IP address has encapsulated. This is what we call it as VPN. Instead of showing this actual source, because this 22221111 is not reachable in the cloud. Assume if you have a layer 3 device here, they don't know what is 1112222. But what they know is this physical interface addresses. So that has been encapsulated. The routable address is added on top and the packet is routed. This is what we call it as VPN, having encapsulation. This packet is not routable, so you put this address is not routable, so you encapsulate with the routable address on top. So in real world, this source and destination will be a private IP address which is not routable in the internet, and this will be the public source and public destination. This is what we call as VPN. But the problem with this VPN is it is not secured. Why? These information, see, the actual source is 2222 is revealed to the public. And what packet you are sending? ICMP packet. It is revealed. This is not encapsulated. This is just encapsulated. It's not encrypted. When I do IPsec, ESP protocol, encapsulation security payload, that protocol is going to hide these 2 steps completely. These 2 steps will not be revealed to the public. Now public can see from where the actual source is coming. 222 is the actual source. 111 is the actual destination. And what type of packet? It is an ICMP packet. Public can see. But when I enable ESP protocol, these 2 layers will be totally encrypted, will be hidden from the public. All that you will have is only these 3 layers. And this will be a ESP packet. ESP means encrypted packets. Here just an encapsulation happens. GRE is generic routing encapsulation. It is not encryption. If I add IPsec to this, that will become encryption, which is a secure tunnel. Right. So let us now remove EIGRP from here and put OSPF. Now,
Okay, sir.
the reason why I am enabling OSPF is because you are using tunnel interface. R1 and R2, according to the tunnel interface, they are non-broadcast multi-access network. They are NBMA network. No router EIGRP 10. So you know how OSPF behaves in NBMA network. How they won't form neighbor dynamically. If you want to form neighbor dynamically, you need to change the NBMA mode. Now let me remove first EIGRP and then I'll do that. Yeah, in OSPF you don't have the problem of next stop self or split horizon. So no need to worry about those two commands. You no need to have that commands on the tunnel interface. You remember sometime before we gave no next stop self split. No need to do that for OSPF. Now I'm going to say router OSPF process ID network 1.0.0.0 0.255.255 area 0 network 192 don't say because that's physical interface 172.16.0.0 0.0.255.255 area 0. That's it. Now similar configuration I'm going to do it on other two routers.
So that one is /24 now, the tunnel.
Not necessary, you need not to exactly match. What I'm saying, what is the meaning of this? I'm saying if these two matches, if these two octet matches on any interface, run.
Okay.
Same here also. I have 32 on the loopback, but I'm saying just see if one is matching, then run OSPF there.
Okay, sir.
Now I'm going to copy this and then paste it to a notepad, alter this for the other two routers. Oh my God. Okay. So enable config T. I enable OSPF. If you want, I can show you what the command and show IP OSPF interface brief. I'm pasting this on R2. You will see what all interface that runs OSPF.
Okay, sir.
You see? One more time. It is running on tunnel interface. Oh, the problem is I didn't change this. It's not 1, it should be 2. Correct?
Yeah.
So
yes.
I'll put no here. You see, I'm not running OSPF on the physical interface. I run only on this two interface. Next, it's similar change that I'll be doing on router 3. So here it will be 3. Router 3. Done. But I don't see neighbor. See, show IP OSPF neighbor. With router 1 I see it is in extract state. Okay, it has gone full state. Again it is going to extract state. Let me go to router 1. Show IP OSPF neighbor. See, I'm not seeing neighbor stably. See, where is R2? R2 is missing. The reason is this. Show IP OSPF interface tunnel 0. You see, show IP OSPF. This iOS is quite different. Okay, this will be fluctuating like this. If you want to solve this, all that you need to do is you need to go under the tunnel 0 interface, okay, and say this command: IP OSPF mode, process ID mode IP OSPF 1 IP OSPF network type IP OSPF network type just say broadcast. That will solve the problem. So I need to just say this command: IP OSPF network type broadcast. Try to do it on all the routers. If you do on one router, it will solve the problem, but try to do it on all 3 routers. Give this command: change the mode as network type as broadcast, interface tunnel 0, and these two will form neighbor now. Interface tunnel 0, done. Now we are going to form a neighbor. Don't do this on the physical interface. Physical interface don't know anything about your OSPF. Now on router 1, show IP OSPF neighbor. Okay, here we go. But the problem here is router 3 is elected as a DR. We want hub router to be a DR. So what you will do? Interface G0/0. What you will do? You will give the priority. IP OSPF 1 priority. IP OSPF priority. Give the maximum priority 255 and clear the OSPF process. Clear IP OSPF. You need to do this especially on the existing DR. Who is the existing DR here? Clear IP OSPF. Alright. So now let's go to router 1 and check the neighbor. Show IP OSPF neighbor. I should see. Come on, why R2 is a DR? Just give me a minute, I'll refresh on R2. Clear IP OSPF. OSPF neighbor. In OSPF there is no preemption. I should have given the priority long back. Clear IP OSPF process. Right. Now I should see both having full, come on. Yeah, correct. So R2 will also have full neighbor relationship in some time. Right now it is in egg start state. So who is DR now? R1 is DR and R2 and R3 are going to have full relationship with this. We need to wait some time. Yeah, see, full state. Alright, that's it. Now if I go to R2 and check the routing table, show IP route OSPF. I'm seeing 333 and I can go directly ping 333 with a source of 2.2.2.2. I'm able to ping successfully spokes to spokes. So this is what all about DMVPN without security, and today we have seen DMVPN configuration, and I have also explained why we need those configuration and how DMVPN works. We have also done with two different routing protocol the variations we've seen, and tomorrow we will be continuing this with security. I'll give you an introduction of IPsec and what VPN is, secure VPN is, what all protocol involved in encryption, and then for integrity and for a transform set and the pre-shared key, why do we need all those stuff we will discuss, and then we'll provide the same topology, the GRE, multi-point GRE, which is called DMVPN, as secured communication, right? So hope this was useful for you today. Thanks for joining. See you tomorrow.